When you say kinematically, can you explain to us what you mean by that? And as well, what would you say dynamically mean to you?
Well, in this concept, right, where let's go back to the very beginning where we talk about the helicopter that just takes off and hovers in the air, right? Now, there's nothing to show that the plane's going 500 miles an hour with the rotation. We agree on that, right? He's just going 0 miles an hour hovering over the Earth, right?
Yep.
Right? So, kinematically, mathematically, we can think about it that the helicopter is automatically going at 500 miles an hour eastward, but there's nothing to show the dynamics of that happening, because according to the pilot, he's just going 0 mile an hour hovering in one spot. Do you agree with that?
Yes, but
Okay, there's the
right.
difference.
Kinematics doesn't just mean mathematically, and dynamics means in real life. That's not what those words mean in
Well, with
physics.
the dynamics, when you add the dynamics, right, you're adding the masses in, right, and you're actually showing the relationship between moving bodies and their relationship to each other, right? So that's when you add the mass in to the kinematic concept. What you could also do, you could say you could put the m in the equation, right? But to show the physical dynamics, you would have to have a real world situation where you're saying, okay, here are the actual forces that's causing the plane to go along with the Earth, right? And back to Lion's point at the very beginning, which you made a very good point. As soon as you take off, that 500 mile per hour conserved momentum would start to dissipate automatically because we have resistance of the air. So just assuming that the helicopter could hover for very long and keep up with the Earth is already
What do you
begging the
mean,
question that it
man?
would
The
keep that up
air
for very long.
molecules don't just dissipate the helicopter's momentum, they also
Uh-huh.
provide it with momentum. Like, why don't
Okay,
you get that? It goes both
I do
ways.
get that. I do get that. But I'm saying to assume that the helicopter that goes straight up in the air and just hovers for like 20 hours, to assume that this original conserved momentum of him being on the ground, which is what the globe says, the reason that it's moving with the Earth is because it was on the ground, not because the air is moving it with the Earth. It's because the helicopter was on the ground, right, Jayace?
Wait, they do say that. We've been saying
Because
to
the
you that the atmosphere moves
ground,
with the Earth.
Right,
the
but
helicopter
not
was
for the one at the same
attached.
latitude.
The
Not at the same
helicopter
latitude.
was
They
a,
say it's because it was on the ground,
oh
not
my
because the air
god.
is
Yeah, but the
moving it.
helicopter's hovering in your example. That the latitude doesn't even matter at that point.
Well, that's
Yeah.
that's the
And when it's
concept.
on the ground,
Because
it
there's
doesn't
nothing to
matter
show it's going
either,
500 miles per hour eastward,
because
right? That's why it's kinematics versus dynamics.
the earth has
Okay,
the energy and momentum to move a helicopter. It's orders of magnitude larger in mass, so it's going to move the helicopter with very minimal subtraction of its momentum vector in that sense. Then when it starts to hover, then the helicopter is exchanging momentum with the air, both in the negative and positive acceleration directions.
Uh huh. But
new
so
new
you're saying that
perspective.
at some point the 500 mile per hour conserved momentum will dissipate, yet the air will keep it in sync with the
It
Earth,
doesn't
even though the
dissipate.
pilot has
That's
no
not
idea.
how the conservation of momentum works. It doesn't change if it's hovering. There'll be very
Uh huh.
small fluctuations around 500 just for the immediate changes in the immediate environment that the helicopter is in. But other than that, its tangential speed is going to remain that 500 miles an hour, dude. It doesn't subtract, it doesn't add until it starts moving.
Right. So you're saying that the conserved momentum of 500 from being on the ground stays with the helicopter indefinitely, or is it
Yes,
the air
because
that starts to move it?
Until it runs
What are you
out of
saying?
gas. Until it runs out of
Okay.
gas, then
So, but that's the momentum from being
it
on the
can no
ground.
longer offset the gravitational vector, and thus it will begin to drop to the ground.
Right. I'm asking though, are you saying that it stays at 500 miles per hour in perfect sync with the Earth because it was on the ground, and that's where the 500 comes from? Or are you saying at some point
Yes,
the air
it
starts to make it
has the
going 500?
momentum that the ground has, but the air
Okay.
also has a momentum very, very akin to what the ground has at that location.
Well, what about if it's westward winds at that particular location heavy westward winds all day long. Is the 500 miles an
So
hour
then
going to
the
just stay
velocity
slower?
will, if you were keeping track of that tangential velocity, right, and the helicopter was hovering and a wind came the opposite direction or whatever from the Earth's and the air's normal momentum at that location, then yeah, the velocity would slow down for, you know, while that gust was going by. That's why pilots have to pilot when they're flying these things, right? He'd have to maneuver the craft to keep it in the air.
Well, I'm asking how would you show me the dynamics that we could prove that the plane is going 500 miles an hour with a rotation, even though it's going 0 miles an hour, hovering in one
From the
spot?
instruments,
How would we
like I
prove the
was
Okay,
telling
new,
you
dynamics other
before,
than the
the
mathematical
instrument.
concept?
new
How
The
I
perspective.
was
instruments show
telling
that?
you
I can
before,
clarify.
with the
Wait, the instruments show
Ataru,
the
with the
500 miles per hour
Adirs,
eastward movement? Wait,
they don't.
what instruments are showing
The
that?
instruments, you have to go. They don't display that information to the pilot because it's not something the engineers think the pilot critically needs to know. But it does display that information for engineers to go and retrieve and look at. That can be done.
Why would they think the pilot wouldn't need to know that he's going 500 miles an hour eastward?
Because the pilot is worried about keeping the plane in the air so he doesn't crash and die, or helicopter. So things critical to that are all he really needs to know. You don't want to overload. You don't want to give a human being information overload when they have a life and death task at hand.
Well, I think that 500 miles per hour eastward momentum would be something that would be a life and death matter that the pilot would want to know about. Why keep it
It's
from him?
not.
And where would
It's
it be measured
not.
from?
External reference frame. It's an external reference frame. For him,
That's the
he's
way you
going
think about it.
0.
Right.
Yes,
So you're
exactly.
saying that they're keeping this information, they
Where
have this information, but they're just keeping it from the pilot because they don't want to
Yes.
overload him? Is that your theory?
Yes. He has a task
Where is this
that
information
is,
coming from?
there's a threat of immediate life and death danger, right? So you do
That's what I'm
not
saying.
want to give him information overload with a bunch of information he doesn't need to know. When he, especially helicopter pilots, they have to react extremely quickly. So you definitely don't want them searching a million gauges to find the information that they need. You display
Oh,
the
really?
information.
This seems quite convenient, though.
In the
So
air.
wait a minute now, Jayace. So you're saying that they have a reading of the 500 miles an hour tangential velocity?
Yes.
They have the reading. Well, where's that
Yes.
reading
no,
coming
On
from?
an
no.
airplane, it's
Where's
called
that
an
coming from?
Ataru. On an airplane, a commercial airplane, the system has a name. It's called an ADIRS, and then the instrument itself is called an Ataru.
I know what
No,
those
Jay.
are.
No.
They're
It's a
not saying
semantics.
that they're not showing the pilot that he's going 500 miles an hour or the ground control that he's
Dude,
going
because
500
I
miles.
just
There's
told
no
you they
reading
don't
of this
need
500
to.
miles an hour.
I
They
just
don't
No,
need
told
to,
you
but
they
they
don't
Jay.
need
could if
to.
they wanted to. Where would
He's
this
playing a
reading be coming
semantics
from? Is the
game.
question.
No.
This
He's
is
not saying
silly.
he's not saying that they're showing you a measurement of that. He's saying that the system they've provided the pilot and the plane, that's already a presumption in there.
That's what I'm saying.
Yeah, okay, so we're on the same page. So just to clarify,
It's
it, on
information
one hand, it sounds like
retrieved.
you're saying you don't have a problem with the math. It sounds like your overall issue is
It's
the
not
proof
math.
that the globe is spinning. No, I'm talking to him.
Yeah,
It sounds like
Jay Ace is making it
yeah.
sound like they have
The
this 500 mile per
information
hour reading,
is
but they're not letting the
presented.
pilot know about it because they don't want to overload him.
The information is presented. It's all the Ataru and the ADIRS
How?
measures all of that stuff. It just doesn't display it all to the pilot. It only displays things that are critical to flight. An engineer, when the helicopter lands or the airplane lands, an engineer can go and they can retrieve that information afterwards from the
Really?
system.
This is awesome. Really, I have no idea. So you're saying there's a secret
Well, that's
gauge
kind of
that is
sad,
in
dude.
the thing that they can go back and say, look here, it went 500 miles an hour from the very beginning. It was already moving eastward at 500 miles an hour. We didn't want the pilot to see this gauge. We hid it from them.
Bro,
But we can go
it's
back later on in this
just,
black box
bro, you
situation
just
and show
sound
exactly how fast
so
the plane was going
pompous.
eastward.
Stop.
What?
Well, this is why it's
You're
related to
kidding.
the how it's related to the Sagnac effect and to interferometry, because it's part of that is the laser gyroscopes they use in the airplanes that have to factor this difference in from the Sagnac effect.
Right, which is a totally
Well, the
different thing
thing
than
is,
rotation.
right, like this gentleman, New Perspective, is claiming he knows this stuff better than the engineers, but he doesn't know that they can go into the Ataru and the ADIRs and retrieve all this
I'm not
information he's
claiming
asking
anything,
for.
Jayace. I'm not claiming anything.
It's
I'm asking
pomp.
about your claim.
Well, they're
It's
not getting
pomp.
You're claiming
information of
that
a
they know
rotating
this.
globe. They're not getting any information from a rotating globe in that equipment. They're just getting the,
They
like I
are.
said, the
Jayace.
actual Sagnac effect is what
That's
is what
your
it's
claim,
related
not
to.
my claim.
All of that information is contained in the readings, and they can easily retrieve it.
Oh, really? That'd be interesting to find out. Would
Yes,
show us
when you
information,
say,
show us
"Oh,
proof of
really?"
that.
like a fucking moron, you just sound
Oh
pompous
yeah, I'm
because
such a fucking moron. They're keeping this
you're
500-mile
Yo, don't
trying
tangential
call
to
names.
like
velocity
Don't hold
hidden
on. I
from the
gotta stop
pilot.
this. Stop, Dave, Jace. Don't call names, please.
Yeah,
Yeah,
Jace,
guys
you
and
are
don't
you're
have
a
to
talking
do
past
that
moron.
each other.
Of course they would hide this from the
because
pilot.
you're
They
not.
don't want to
this
confuse the
guy.
pilots.
This guy's killing.
Don't let
You're a
Dude.
moron. That's
All
so
right, let's
funny.
not do the insults
All
and
right,
stuff. But
there
Jace,
you
you
go.
don't Jace, you don't have to do that because you're not incorrect in what you're saying. So you could just stay strong and not have to insult.
Yeah.
Oh wait,
We can
Gio,
move
didn't
on.
you just say he was incorrect, Gio? Didn't you just
No,
say
I
that's
said
not information?
no, I said it is.
That is
It is
all.
in there. You know, like the whole 15 degrees an hour and how that links in with the gyroscopes and the laser gyroscopes they use in airplanes. That's connected with their systems. So
Right.
it's just the
Which is a separate
interpretation of
thing.
what is causing that, whether it's Earth rotation
Exactly.
or. But it is in the
Exactly.
equipment that they have to factor for because ether drift is
Right.
real.
I agree with that. Right. And that's the confusion we were trying to get at the very beginning. This 15
No,
degree an
bro.
hour is not
But let's just
necessarily a
move
500
on.
mile per hour tangential velocity. They're two
It's
different
not,
things.
but let's just move on.
Yeah, because you're wrong.
But Jace, that equipment, hold on.
Sure,
When
whatever.
you're saying it's in the
You
equipment,
win.
well, hold on. When you're saying, dude, no, it doesn't have
Congrats.
to be a winning. Let's just stick to the information. So, Jace, what you're talking about, you're not saying it has like Earth rotation values. What are you claiming it has exactly? What is the value you're claiming it has? Are you talking about the Sagnac effect? I was the one who brought that up. So,
Oh, it
is
does.
that what you're saying, or yeah? How do
It
you want to
certainly
explain?
has the Earth rotation value, right? The pilots, when a commercial airline like a 747, 737, a Boeing or an Airbus, when they turn it on, the gyroscopes measure that rotational rate, the degrees per hour of the location that they're at, and then the pilot, in order to finish the calibration, so they have to let it sit there and calibrate, measuring this rotation for a few minutes, and then the pilot has to input the other coordinate, the longitude, I think it is, to finish the calibration. And then throughout the duration of the flight, that gyroscope, that system, is measuring all sorts of deviations from that original position. And you can retrieve all that information out of those readings. It's directly measuring what the rotation of the Earth is doing to these systems.
All right.
Yeah, so
I
I
guess
don't
we
disagree.
gotta
I
shut
don't
it down.
disagree. I don't disagree that it's picking up the data that you're referring to, but the question is, what is the cause? Is the cause Earth rotation, or is the cause
Yeah.
the actual medium itself? So, but yeah, I mean, just in that part of it alone. That's why I was bringing it up earlier, because basically in this whole explanation of how planes fly, in the globe model, they just basically replace Earth rotation with Sagnac effect. Or there's an inversion, in my viewpoint, that's done there. So it does work in a way. It's more about what's causing the difference rather than,
Yeah.
like it works in both in a generalized sense, but it's more like what is the cause and what are the deeper components of it that I think that there's, points to be made and things to be explored within the differences.
Yep.
Yeah, can I make a
Yes,
point
that's
on
why.
the calibration? Can I make a point on the calibration? I'm not aware that any aeroplane is calibrating the rotation of the Earth. Calibrating horizontality for the pitch of the aeroplane for the flight it's about to take. That's it. That's all I'm aware of.
Pilot, Jen, Mentor Pilot. He's a YouTube channel. He's a commercial pilot. He flies Boeings. He literally videotapes himself going through this calibration process. So just look at what he does and what he says. The channel's called Mentor Pilot. It's in the video called "Can Aircraft Fly with Two Lasers or with Lasers?" That's the title of it.
Yeah, it's just a calibration for the sidereal rotation, the Sagnac effect, and all these things. which could just be a sidereal rotation, which is what the 3-ring laser gyro is picking up, Jen. And it doesn't have anything to do with the 500 mile per hour conserved momentum or any of that. It's just the 15 degrees, which you could call 500 miles an hour at that latitude. But there's no proof that the plane is moving 500 miles an hour along with an atmosphere. That's just the concept.
But you could claim that, but it oddly satisfies the thing that you were just arguing about.
Yeah, I'm posting
You'd
the
have to
video
clarify
of
what you're saying
Mentor
about
Pilot
that.
doing this. I'm going to post it in the chat right now.
Dave, let me ask you this,
and-
Dave.
Yeah.
Okay, if you have ether drift, okay, a very gentle drift, okay, and that is going at 500 miles an hour. Okay, I'm not claiming this is the case. I'm just asking what you think. If you have ether drift that's going 500 in the north and then 1,000 at the equator, do you think you would have to do anything over a stationary Earth to account for that, or would it just be minor?
That's what I'm saying, Gio.
whole way?
Totally. It's not that. That's not the thing. It's not the ether drift wouldn't be going 500 and 1,000.
I'm
The
not saying
ether,
it is. I'm just
the
asking if
Coriolis.
you replace it. I'm just asking if you replace it.
Yeah, but that's what I was trying to explain before. That Coriolis correction is a westward deviation, right? And that could be the 15 degrees that we're talking about with the Sagnac effect or the sidereal rotation. But that's not saying that the wind is going 500 miles an hour at that latitude and the wind is going 1,000 miles an hour at the equator. That's totally different. It's a totally there's a slight westward deviation that might happen because of this quote unquote Coriolis that they're conflating with this possible ether wind. But the idea that there's a wind that's going to carry the plane twice as fast eastward is totally a separate thing than that, in my opinion. It's the opposite direction, in fact. The wind, if it was a wind that was going to push the plane eastward, regardless of its forward speed, twice as fast eastward, it would be the wrong direction because the Coriolis force is a westward deviation, right? So you would have to think about the wind pushing it the opposite direction for that correction. The correction it needs is an eastward, twice as fast eastward velocity, regardless if it just went 100 miles an hour all the way to the equator. We have to think about it going from 0 to 1,000 in a little Cessna. Now we're assuming that this wind carried it from 0 miles an hour to 1,000 miles an hour without the pilot having any idea that that even happened. That's the ridiculousness of the literal claim of the globe.
Did you hear the motorhome with the drone analogy I gave?
Yeah, that's again a non sequitur a little bit because it's one linear direction. We'd have to worry about the rotation as well as the oblateness and the fact that it's going in a curved direction. You would have to follow. You would have to lead the target, right? Just like the diagram that I always post that Jeremy agrees with, and he agrees that you have to curve your path. So all the flight paths would be different according to what they're saying because your destination is going 1,000 miles an hour. And then you're flying you're starting out with an eastward tangential velocity of only 500. So you're going to have to constantly accelerate to be in sync with an Earth with a destination that's moving 1,000 miles. So you would have to lead the target to even get there to begin with. And then you'd have to imagine the atmosphere carrying your plane at the exact same rate as you're going in the opposite direction to land. That's the absurdness of the literal claim that the globe believers have to say is not a problem.
Dave, I've gotten two hardcore Globers to agree with me on my plane argument.
One was Moyak.
Hardcore Globers.
I agree with your plane argument. You don't, but you agree that the surface will be moving at a different speed tangentially than the plane, which is the whole argument, Jeremy. You agree with that, but then you say their argument, the globe's got it, they have it all figured out, their model works, but in their model, the eastward tangential velocity of the ground is never moving at a different speed than the planes. They're saying there is no Coriolis.
They are saying there's Coriolis. I don't know if you don't know how to get it or not. You have to change your tangential speed. Then you get the Coriolis. You get a little course correction. But now you're in a medium that's moving at a different tangential speed. So when you're in a medium that's moving at a different tangential speed, it's going to move you with it if the medium can support your object, which is plane is doing easily. Boats, planes, balloons,
if it's moving you in perfect sync, if it's moving you in perfect sync with the ground, which is the claim, then you have no Coriolis.
No, that's not true. You get the Coriolis. It's moving you in perfect sync until you move. Then you get the Coriolis effect, and you're in a new tangential speed. What you're saying is not
the plane
true.
is moving eastward at a different
It's not.
pace.
You're saying something
than
that's
the
just
ground.
blatantly wrong.
No, but you're saying opposite things, Jeremy. You're saying that the eastward tangential velocity of the ground is going to be different than the eastward tangential velocity of the plane, right?
So when you're in the
There's
water,
going to be a difference. There's going to be a difference. You're at 499.
If the atmosphere is moving it along
You're at
501,
490. Come on,
502,
Dave.
there
I
would
know.
be
I
no
don't. Come on,
difference.
man. Can you guys hear me or?
Well, Jeremy, I'm saying that if you're saying that
Yeah,
the
we hear
atmosphere
you
is moving it
fine.
along,
Yo, Dave,
He
you gotta chill.
interrupted.
then there is no difference.
Dave, you gotta please, dude, chill for the audience, dude, for the audience sake, bro. I know you're eager and you're excited, but you gotta chill, bro, please.
The plane's at an
I guess
area.
I feel like I'm trying
The
to
plane's
say
at an area
things.
where it's Dave.
Go ahead.
Please, man.
Go
Plane's
ahead.
in an area where it's going 500. Okay, thank you. The plane's in an area where it's going 500 miles an hour. It's going to move to an area. Right now, it's just 500. It's just, let's say it's a helicopter. It's just sitting there. The air is dragging it along with it, 500 miles an hour, la, la, la. Then it's going to go to an area where it's going 501 miles an hour. Here's what happens in the globe model. You're changing your tangential speed. You get a Coriolis course correction, and you're also now in a medium that's going 501, which according to fluid dynamics is going to drag the plane along with it, like Gio told you an hour ago, at 501 now, because that's what mediums do. Like inside their model, there's no problem with what you're saying. It's a non-issue.
So when you're talking about the water,
real quick, I have to clarify this with Jeremy. What I was saying is, if you're saying that the plane is moved along perfectly at 501, 502, 503, that means that you're saying it's moving along with the surface exactly the same speed. So there would be no difference. You're saying there would be no Coriolis if you think it goes 501, 502, 503 perfectly, because then there's no tangential velocity difference. That's the problem.
No, I just explained it to you, dude. I just explained it to you. The helicopter's at 500. It's going 500 with the air, with the ground. Everything's moving at 500. It goes to go into a new area of 501. There's a tangential speed change, which was going to cause an apparent deflection. It's the Coriolis effect you get off of that. And the plane's now in a medium that's going 501. So it's going to get dragged along with it at 501. There's no issue in what you're saying. It's not even a problem in the model.
But no, we're talking about the tangential velocity of the ground compared to the tangential velocity of the plane. What you're saying is different because there's a Coriolis effect.
Yup, you change your tangent. You know how you get the Coriolis effect? Nobody gets this. You get it by changing your tangential speed. That's the only way you get the Coriolis effect.
That's not true. But there's a gentleman who's
That
been
is
trying to get in.
absolutely 100%
Jeremy,
true.
you still don't get this at all. I'm gonna have to do a presentation because every time I talk,
Jeremy,
it's like, okay, Dave, don't try to say more than one sentence, Dave. I know you're excited. No, I'm just trying to explain my argument, and you're still not getting it, Jeremy. I'm just gonna have to do a presentation and actually show this to everybody so they get it. I'm sorry.
There's no argument. It's just you're not saying like inside their model, they got this part of it covered. Like they're good. There's no issue here.
Yeah, the global model works perfectly, but there's a tangential velocity difference that I want to point out my plane argument where I'm saying they would have to lead the target because of the tangential velocity difference. But at the same time, I want to say, no, the global model has it all figured out. There'd be no tangential velocity difference because the atmosphere makes it go 501, 502, 503 perfectly. That's what you're saying. It's opposite, dude. You're contradicting yourself and you don't even realize.
Okay.
There's no contradiction. There's no contradiction. First of all, in my argument, they don't have it covered. And the thing you're saying, they have it covered in their model because the air is moving. The air, you take off at 500, you go to 501. There's a Coriolis effect happens, and the plane or helicopter is now in a medium that's going 501. There's no problem in their model with what you're saying, dude. It's just it's not a thing.
So is the tangential velocity difference. You're saying there would be no tangential velocity difference, and there'd be a Coriolis effect, which is the tangential velocity difference. You don't get that?